Welcome to the Project Lead the Way instructional resource, Introduction to ROBOTC Features. Input is required to continue when the interaction icon appears in the lower left-hand corner of the screen. To begin, open ROBOTC for VEX Robotics by selecting the icon. Once ROBOTC is fully loaded, the PLTW ROBOTC for VEX start page will be displayed in the main programming window. The start page provides a user with up-to-date information regarding ROBOTC, including additional resources and software updates. Before programming, the user must select the platform type that will be the target of the program. This choice will customize the programming environment for that platform. The platform type that you will use to complete all PLTW curriculum activities, projects, and problems is VEX 2.0 Cortex. To choose the platform type, select Robot. Select Platform Type. Select VEX 2.0 Cortex. The Natural Language Library allows students to utilize natural commands like forward as well as traditional motor commands. To choose natural language, select Robot. Select Platform Type. Finally, select Natural Language PLTW. Verify that VEX 2.0 Cortex and Natural Language PLTW are selected each time ROBOTC software is opened. To aid beginning programmers, ROBOTC software provides users with a sample program library. The sample programs are fully functional and include comments to help decipher the program. You can use a sample program as a base to start and build your own program. Let's load and explore a sample program. Select File. Select Open Sample Program. Select Bumper and Limit Switch. Select Wait for Push 1. The new lines at the top of the program are configuration functions known as pragma statements. Pragma statements are input and output configurations that are needed to make the sample program function properly. Program comments provide users with information to better understand the program. They are ignored by the program compiler and have no direct influence on the program. Program comments are created by the programmer at the same time that the code is written. Notice that all comments are color-coded as green and begin with 2 forward slashes. The main content of the sample program is what will drive the actual robot behavior. All programs in ROBOTC start with task main. The left side of the main programming window is the text functions window. The text functions window makes programming more user-friendly by listing predefined common commands. ROBOTC software interface and the text functions window can be customized to better meet the experience level of a user. All PLTW activities, projects, and problems will utilize the Expert menu level. To set the menu level, select Window. Select Menu Level. Select Expert. Notice the change in the text functions window. Even if it has been written correctly, your program will not work if the inputs and outputs are not configured appropriately. The motors and sensors setup is the interface between your physical arrangement on the Cortex and the logic of your program. To access the motors and sensors setup window, select Robot. Select Motors and Sensors Setup. Within the Motors and Sensors Setup window, several tabs are logically grouped according to standard models and individual components. Select Motors to view the configurations. The field beside each port number provides an opportunity for a user to enter a meaningful name for the component. Our example has 2 motors configured. Right motor is connected to port 2, and left motor is connected to port 3. It is good practice to capitalize the second word in a naming format. Select the drop-down menu displaying the 3-wire motor for port 2. Devices that are compatible with motor port 2 are displayed as options. We don't need to change the default configuration. Other options include reversing the motor controls or applying a digital encoder port and PID control. Select Standard Models. The Standard Models tab contains pre-configured motors and sensor setup information for commonly used configurations. The Standards Models tab allows programmers to avoid setting up repetitive configurations. PLTW test beds are loaded as pre-configured setups. Let's begin building our own program. The first step is to open the PLTW template. Select File. Select Open Sample Program. Select VEX 2. Select the PLTW folder, and then select PLTW Template File. Select Open. Use the PLTW template file to create any new program. The template file provides a header for students to label their file, an area to describe the program's task, and an area to list the pseudocode. Natural language reduces many of the obstacles that new programmers typically face as they learn how to program in a syntax-based programming environment. The natural language library utilizes functions that consolidate commonly used multiple lines of code into commands with recognizable and descriptive names such as forward, stop, and until bump. To view the definition of a command, move the cursor over the command. After any program is loaded, the text functions window will populate with expandable selections. They include control structures, natural language, sensors, timing, and undefined entries. Students and teachers can simply drag and drop the commands into the programming environment. Let's explore by expanding natural language. Select Natural Language. Select Robot Motion. Commands can be dragged from the text functions window directly into the programming window. Drag the command forward into the program within the task main curly braces. Once a command is inserted into a program, the parameters need to be assigned. When using the command forward, the parameter speed needs to be defined. Let's go forward at full speed. Replace speed with 127 and press Enter. Insert the comment Move Robot Forward at full speed to explain our statement, then press Enter. Let's go back to our sample program and download a program to the VEX Cortex. In the text editor window, select Wait for Push 1. After the program has been developed, the next step is to download the program to the VEX Cortex. To accomplish this, we need to specify the download method. Select Robot. Select VEX Cortex Communication Mode. Select USB Only. The other two options, VEXNet or USB, and Competition, VEXNet, may be used by more advanced users. If you change the method, you must download it to the robot and perform a power cycle for the method change to take effect. Connect a battery to the Cortex. Connect the Cortex to a computer using a USB cable. And power on the Cortex. To download a program to the Cortex, select Robot. Then select Compile and Download Program. This sample program runs both motors until the bump sensor is pressed. If there are errors in the program, errors will appear at the beginning of each line. The program must be fixed before it is downloaded to the Cortex. The debugger window enables you to change output values on the Cortex on the fly. Try controlling the right motor by selecting Motors with PID. For port 2, or right motor, select the power output currently at 0. Enter 127 and press Enter. To reduce the speed, change the value to 15 and press Enter. To turn the motor off, change the value to 0 and press Enter. Next, we need to open the sensor's debug window. If it isn't displayed, you can turn it on under Robot, Debugger Windows. Note that the option will only be available when a program is actively running. To explore sensors in the debug window, select Sensors. Sensors cannot be updated manually because they display measurements of physical characteristics. The touch sensor will display 0 if it is not depressed, and 1 if it is depressed. The last step is to save our program. Select the X on the Program Debug window. Select File. Select Save As. Select the location you would like to save your program. Do not use the sample program directory. For this demonstration, let's use a folder called My ROBOTC Programs located in Documents. The location may be different based on your computer and preferences. Name your file with the format, your last name, and a description of the program. Select Save. This concludes the PLTW Instructional Resource Introduction to ROBOTC.